Thanks for that introduction. So Matt and I, as Glenn just mentioned, work for McDonald's Corporate, the global organization here, because as McDonald's operates in 100 plus countries, and our corporate is divided between the markets, as we call the countries that we operate in. We sit in a global corporate organization, so we support these multiple markets that McDonald's operates in. So, Matt, if you can go on the next slide. I'll give a little bit of background on our team here. We work for Data and Analytics Hub team. This is a centralized team. You can call it as a center of excellence for data science within McDonald's. It is a pretty new team. This was started 2 years ago in order to support different functions within McDonald's with data science capabilities. So as I said, since we are in global corporate, we work with, say, the US, UK, with our business problems and try to build centralized solutions, which we can build here globally and then deploy across different markets of McDonald's. So the scale is pretty big. As you guys know, McDonald's, operates in 100 countries. We have like total 36,000 restaurants worldwide. So, everything we build brings a lot of change. It is at a global level. The team comprises of data scientists, data engineers. We even have UI folks on the team. We are doing some cool stuff around data and analytics enablement, which not every market that we are operating in is at the same level of expertise when it comes to data and analytics. So we have teams like data enablement where, we are coaching markets on how to think about the data. Since, it's such a legacy brand, we've operated for years based on the business expertise and business intuition, but our team was brought in to change that culture within McDonald's. And we want the business to take decisions enabled by data. And that's the whole purpose of our team. So the data enablement team actually is going out there in the markets and, just propagating for how data science can help solve their business problems and enabling them with self-service analytics tools. Yep. So as Glenn mentioned, I lead projects around operations analytics and delivery analytics here in Data and Analytics Hub. So one of the projects that we are going to talk about today is Matt and I worked for the past 1 year, and he's going to talk through all the technical details and where we are at globally with this solution is around delivery order inaccuracies. So delivery, when it comes to McDonald's, operates in 2 different ways. If within the US, if you want to order McDonald's via delivery, you have options to order it with vendors, which we call internally as third-party operators. So be it Uber Eats, DoorDash, Grubhub. So you go into the Uber Eats app, and that's how you order McDonald's food. There are some countries, like in Asian countries, we have delivery inbuilt within our McDonald's app. So that's called as McDelivery. So where you can go into McDonald's app and order for your food. Now in the US also you can do it, but in the background actually Uber Eats delivers your food. So it's not totally run by McDonald's, but in some Asian markets, it is completely run by McDonald's McDelivery system. So if you order food from McDonald's, there will be a McDonald's person actually delivering your food. So there are different scenarios in every market that we operate in, like these 3POs. Uber Eats is one of our biggest vendors, across all the markets. The proportion that we have, the share of each vendor is also very different. In the US, we are pretty big with Grubhub. We started the delivery business with Uber Eats, but then we expanded with Grubhub, DoorDash, other 3POs. So the landscape, if you see overall, is very diverse. And when I say our team is global, when we are thinking of building solutions, we have to think about there may not be like a one size fits all answer, but we try to come up with an architecture that to some extent can be taken, like the skeleton can be taken and deployed into different markets. So in this project particularly, like the differences would come from, the different 3POs operating in the markets. So one thing that McDonald's is working very hard right now is trying to align all these 3POs, because all the delivery data you can imagine is transferred to us from these third party operators. So we are working on like aligning all that, standardizing all that, so that we can build some common solutions across all the markets. With the start of the pandemic, in the US, like our front counter, which is like you go into McDonald's restaurant and dine in, was totally closed. Drive through is our biggest channel here in the US. 65% of our transactions are drive through, which were still open, but delivery picked up really fast. And not just in the US, but across the world. So this is like right now one of our fastest growing channel. And we are not into delivery like for 10 years or so. We started with delivery in 2015. So it's compared to the other channels, it's pretty new for us. And with the pandemic, the importance of being in the delivery channel and being there, trying to be the leaders there, was very important for us. Can you go to the next slide? Yeah. So when we talk about delivery, right, the demand is growing. It is the fastest growing channel. So one of the purpose is we want to bring in the best customer experience in there when we are delivering our food. And in terms of delivery, most of us have encountered this, like if we order food on weekends or like evenings, those busy hours, there are many times, like not just with McDonald's, but our order tends to be like inaccurate. If I ordered a fries, the fries go missing from the bag. I ordered a chicken sandwich, but I got a Big Mac instead. I ordered for a drink, but that was never there in my order. So there are like some, these kind of inaccuracies that happen with deliveries. And that leads to poor customer experience. And our focus is to improve the overall customer experience. And with the volume of delivery growing so rapidly, one of the major purpose here is to have these orders accurate. But we were seeing an overall, significantly higher inaccuracy rates across the globe with McDonald's orders, and we want to bring that number down. So the question was, how do we solve it? What would be required in order to solve it? So when our order gets inaccurate, actually, if you order food through Uber Eats and your food gets delivered and you see like those fries are missing, you can actually report through the Uber Eats app that the fries are missing, and Uber Eats will refund you for that inaccurate order. But in the background, the refund goes from the restaurant. So McDonald's has to pay from it. So we are losing like millions of dollars being inaccurate with those delivery orders. And that is why this is one of like strategic priorities for the business in order to improve our accuracy scores when we are delivering our food. So we, in order to solve this problem, we decided to do advanced analytics techniques and understand with certain markets that are actually poor in performance for order accuracies, what is actually driving it. So we decided to build a machine learning model which will help us understand drivers of inaccuracies. Now, I just want to level set here, like we talk about models which are predictive, we talk about forecast models. This is more about understanding what are the features that are driving your target variable, right? So the target here is whether the order was accurate or inaccurate, and then like what are the things that are frequently causing those inaccuracies. So the business question for us for this use case was, when, where, and what products are driving those inaccuracies? What is the data telling us? What are the reasons that we are frequently seeing inaccurate orders? And in order to do this, we built like a rule-based model that Matt is going to go through in detail How did we approach it? What are the different features that we looked at in order to build this model? So just to touch upon, in the bottom here, when I say order inaccuracies, it may be like one item missing. It may be like you get an incorrect item, or maybe like you get somebody else's order. So the inaccuracies here I want to stress on is everything that gets inaccurate in the restaurant. Because we might have faced certain times that you get somebody else's order, and that sometimes happens from the driver's side too. So those are not accounted for here. The only inaccuracies that we are accounted for here in this project are the ones that are inaccurate because McDonald's crew did something incorrect with the order. So we are liable for whatever refund we want to give to the customer. Okay, so what were the challenges in terms of order accuracy? This tool that we built was is currently being used by McDonald's restaurant store managers, the restaurant crew, the corporate staff that works in operations. So there were a couple challenges in here in terms of, as I said in the start, right? We are not operating through a single delivery channel here. We have multiple 3POs in place, and every 3PO is channeling their data separately into McDonald's. So one of the challenges was to build a centralized data repository for all these 3PO accuracy and transaction data in order to track it. So meaningfully, like the restaurant manager should be able to track if Uber Eats, what are the inaccuracy rates in terms of Uber Eats, what are the inaccuracy rates in delivery overall, or like Uber Eats versus DoorDash, to make that difference, right? They did not have that view right now. So before we built this tool, they just used to get like monthly Excel sheets, and they used to go through those Excel sheets and understand the reports. So first was very basic BI level dashboards to understand and track the key metrics. Second is the reducing the cost, right? The refunds we are going to the customer. We have to reduce the refunds. We have to improve the experience. That is another KPI that we are looking for here in terms of getting better in order accuracies. And that would be enabled by the machine learning model that we have developed. And then also, every restaurant manager wants to compare how does their restaurant compare to the overall market or their peers. So, for example, I am in the UK market and I'm looking at restaurant. I own a restaurant and I'm looking at my restaurant, and I want to compare that if I am higher than what the market looks like the entire UK market looks like. That's something that the tool will enable the store managers to compare themselves, so they can benchmark if they are worse or better than their peers or the overall market. So we try to build a web application tool, which is currently being used by McDonald's restaurants in some of our markets, that is enabling them to track the accuracy data, get some insights from the machine learning model, and also like compare themselves with, the overall market performance. Yep. So as I said, there were like in terms of the project goals, right? The problem statement here is how do we enable the restaurants with the right accuracy and inaccuracy information, and then help them understand a bit more about what is driving order inaccuracies. That was the problem statement. So for some of the project goals were identify factors and situations that lead to inaccurate orders. Restaurant level, if there are any situations that are leading to inaccuracies more, so they can actually drill down into those situations and try to make some action, design some actions like operational actions around it. And then also, like as I said, empower the restaurant managers to use this information as a tool in order to make some operational changes, track the data centrally, just enable them with this information, which before this tool actually was in silos, and they were like just getting plain Excel sheets with no ability to track this over time in a centralized location. So that was like an overall overview, a business overview of what our use case is about. And I'll pass it on to Matt to talk about the details of like the features we used, the model that we used, and like some of the results of the models. How is this tool being received across different McDonald's markets that this is deployed in, and the scale at which this is deployed in. Thank you.
Okay. Can everyone hear me okay? Does that sound good?
Yep.
Okay, perfect. So like Dwitiya said, we kind of have our background about why this project is important, but why we need to build a tool to kind of help us uncover this information. So what we did next, oops, sorry. So the next step, now we have our problem kind of scoped out, the next thing to do is kind of identify what data we have available to us and how we can access that data. So the data that we used for this project was sourced from 3 main locations and then brought into Databricks for ease of use and scalability. First, we have the internal point of sale transaction data that relates to delivery transactions. So those are things, a lot of key data points that relate to just the transaction itself. So when it happened, how much it cost, what kind of items are in the transaction, basically key delivery transaction information that we have on the McDonald's side. We also looked at internal POS data that relates to other transaction data across different stores and different channels. So anytime anyone orders from the drive-through, the front counter, information about what they ordered, how much it costs, all the other data comes in as well, and we brought that in as well. And the last bucket is kind of that third-party data that we get from those third-party providers like Uber Eats, DoorDash, etc. And that data contains some more things around the more delivery side. So things like customer ratings, reviews, driver ratings, timestamps in the delivery process, all those things that McDonald's doesn't typically have, but is shared with us due to our agreements with those third-party providers. And that data gets placed into an S3 bucket, and it gets ingested, and then we bring all the data into Databricks to help with our analysis. Databricks is a pretty common tool here in our team at McDonald's. We like it because it makes it pretty easy to scale up clusters, to manage clusters, and also do analysis across different types of languages, all in one location. So it's a pretty common analysis tool that we use for both pre-production analysis as well as production work as well. So now we've got all the data kind of brought into our environments. We started looking through it and started creating some metrics and variables to help identify what is really driving those inaccuracy rates. And we kind of took those variables and grouped them into 4 main buckets. On the top left, we have what we kind of call the operational variables. And so those refer to things that kind of seek to explain the store performance at the hour when the delivery transaction took place. So that includes a lot of basic KPIs such as sales, guest visits, average check, average order size, and all those metrics are tracked by channel, which refers to basically how the customer placed the order, whether it's at the front counter, the drive-through, at the self-order kiosk, or via delivery. We kind of group those channels separately because customers who go to different channels have a very different experience. So typically when we analyze, we'll treat each channel a little bit separately. So then next we looked at kind of a similar idea in the bottom left there. The next set of operational variables was store performance at the day part level when the transaction took place. So this is the same kind of general KPIs, sales visits, average check, average order size, etc. But instead of being aggregated at the hour level, this is aggregated at the day part level. Day parts are pretty commonly used in the QSR industry to refer to the time of the day when an order occurred. So it roughly aligns to like the basic meal that was at the time of the order. So examples of day parts are breakfast, lunch, late night, snack, and we keep them separately because there are often different ordering experiences. A lot of times the menus are different between breakfast and lunch. So we like to group by those day parts to make it easier to analyze. And then the next group of variables that we looked at were around the items themselves. So what type of item, what type of order was the item contained in? Was it part of an extra value meal? Was it only a la carte? Was it part of a Happy Meal? That would affect how the item gets prepared and could affect how accurate those items are. And then the last section is the actual item itself. So what items were present in the delivery order? Did it include things like fries, were there condiments, were there soft drinks? By looking at that, those items that were in the order and trying to map those to product groups, we're able to identify which items kind of are showing up more than others and see if that has an impact on those inaccuracy rates. So next, now that we have the kind of basic level of data and we kind of started creating some features, the next step is to start thinking about how you can put those together into a model. So our model that we're building the goal is to really identify the drivers that are kind of making up the model. So we thought a good plan was to build a model and then use that to kind of identify those important variables that's really driving that model. So we set it up as a binary classification problem where our target variable was a 1 or 0, whether or not the transaction was inaccurate or not. And that way we could use a lot of the classical classification methods that are out there, and it would be a pretty straightforward modeling task. What we quickly realized though was that the data was pretty imbalanced. The target class was pretty underrepresented in the data, and there's a pretty severe imbalance between inaccurate orders and non-inaccurate orders. And that kind of creates some problems with us because, you know, even those classification methods are very useful, a lot of times they don't work as well and they kind of break down when they're dealing with a very imbalanced class. And in this case, when we're dealing with inaccurate orders, you know, some people may think that inaccurate orders happen a lot, but in actuality, and in the data, they don't happen very much, which is good, but it's also bad when we're trying to predict that because that makes it hard to build a robust model. So we try to deal with that in a few ways that we could. We tried oversampling the target variable. We tried undersampling the minority class. We tried creating synthetic data points with the smoke technique, but there really was no kind of magic bullets that really helped us totally fix the problem. And we ended up kind of having to make do with the data that we had. We went through a lot of iteration between finding the right algorithm. So there are a lot of classification algorithms to choose from. We cycled through a number of them, including random forests, XGBoost, logistic regression, just to make sure that we didn't miss anything between the different models. And while we're doing this, a key point that we were also doing at the same time was communication with stakeholders. For this project, a pretty high priority was placed on explainability. So for us, it was very important to make sure we were building a model that our business users could understand, and our business users could easily figure out what was going on and why the model was saying the things it was saying. So it's very important that the model was easy to understand for all users and that the output was very clear. At the same time, we're also building a tool that's essentially brand new. In the context of McDonald's, delivery has not been around for that long, so there's still a lot of efforts to measure the data, measure the accuracy, and trying to fix the problems that are inherent in the system. So to build a tool from the ground up was kind of a greenfield project, and it made it very important for us to continually work with our stakeholders to make sure we are collaboratively defining how we wanted this tool to shape out in the end. It was also important to consider the end user and organizational structure around the tool. While we were putting the tool together, we really tried to think about how restaurant manager would use the tool, how it would fit in with the other tools, and that helped us decide what the best plan of action was. And overall, iteration was key. We kind of went back and forth, and each time we iterate, we check in with our stakeholders and tell them about the different paths we've taken to make sure we're both on the same page, and then we'd be able to iterate from there with new ideas. So iteration is very important. And it was so important that we wanted to actually keep track of the different types of things that we tried along the way between starting the project and kind of finishing the modeling phase. So they've kind of been assembled into this table here, so I can talk through the different things that we tried along the way, just to give you an idea about the types of strategies that we attempted and why we attempted them. So we frame this as a clustering problem, right? Initially, in order to see if, well, maybe if we clustered similar stores together, we try building a different model in each store. From there, we also tried, as I mentioned, classification problem. How can we kind of start with random forest and pull out that variable importance to use that as a way to identify which factors are driving our target variable. That was a pretty good baseline way to start to identify what's kind of jumping out in the model. We also use a lot of different classification techniques, variable importance techniques from there. Obviously, there's lots of different classification algorithms that we could use. We kind of cycled through, tried different ones, and looked at different ways to measure variable importance. We also looked at different ways that we can maybe represent the variables differently. We tried taking variables and reducing them into quartiles so that we could easily communicate and understand how variables are affecting the response. We also tried for more general binning of the variables to help us identify those different ranges of the values that had a high impact on our target variable. And then we also tried some decision trees as well. That was more of a business rule focused output that would help us kind of zero in on those insights in the business rule context and less in a model variable context. And then from there, we kind of made the jump to more of a decision tree optimization that allows us to focus on those highest impact areas. And I'll talk a little bit about what that means next. So as we're kind of going through our modeling approach, as I said, we started off with the classification task and kind of moved towards what we ended up on as a decision tree. So the way the decision tree works is we still kind of framed it as a binary classification, right? So our target variable is still whether or not that transaction is inaccurate or not, 1 or 0. And then we took that and we kind of applied a decision tree to each store in order to generate a unique model for every delivery store. We looked at 1 year of delivery data so we could limit the amount of data we're using for our MVP. And then we kind of took that decision tree and use it to help extract the operational metrics that really kind of highlight those opportunities around improving that order accuracy. So how does that work exactly, right? So the way a decision tree works, I'm sure a lot of you are familiar with how decision trees work just based on the role they play in random forest algorithms, but they can also be used as a standalone tool as well. When I worked in fraud and fraud detection in the past, we used decision trees pretty frequently because it's a good way to really quickly identify where you have large pockets, large concentrations of your target variable, and then quickly understand why those pockets are being caused. And that allows you to quickly identify if there's any fraud, or in this case, if there are any big groups of inaccurate orders that we need to be aware of. So using that same logic, the way a decision tree works then is that you kind of start with your population at the root node, and then at each node along the way, as you step through it, it gets split in an attempt to maximize the purity of the node. And what that boils down to is in the end, as you get further down, you're left with the node at the bottom, where the nodes are split to be as pure as possible. In practice, that means that you have a bunch of nodes that basically represent large pockets of your target variable. And in our case, that's exactly what we want, because we can kind of go back and retrace our steps up the tree and figure out why the splits were made. And those splits can then translate to business rules that tell us the exact situations that lead to those pockets of high inaccuracy rates. So this is a pretty cool solution for us. There are a lot of positives to using a decision tree. I think the biggest thing is that it's a very clear and straightforward and easy to understand algorithm. So it's very easy to see why your decisions are being made the way they are. It's also very fast and scalable. So it's not a problem if you just scale up to hundreds of thousands of stores or multiple markets across the globe. And it's also very easy to reverse engineer and understand your outputs. And all those aspects are exactly what we were looking for from our tool. So we have our decision tree. We build a decision tree, and we use that to kind of take those business rules that tell us exactly the situations that are occurring when we have high pockets of inaccuracy rates. But the problem with decision trees is that by themselves, they're unstable. And that's why random forests are used for predictions, because when you have multiple decision trees at once, it makes it more robust. But if we're using just one decision tree, then it could be unstable. So how do we fix that? Well, what we ended up deciding to do is kind of creating a custom code simulation that went through an optimization and created many decision trees for a given store, and was able to select the optimal decision tree based on the criteria that we identified. And I mean, that's kind of an open-ended question, right? Is what is an optimal decision tree? So we had to outline what we wanted to identify as kind of our best decision tree, and how how we'd be able to like select that based on the other criteria. And then based on that criteria, the simulation basically maximized the number of inaccurate orders it was able to account for while still submitting to those criteria. So at a high level, then the way it works is it just builds a bunch of trees, selects the optimal one, outputs that optimal tree, and from there we go back, identify those nodes that have the highest inaccuracy rates, and read those back and determine what those variables were that contributed to those high rates, which we can then translate into business rules, and we can translate to our end user. So it all kind of works out nicely. The other bonus of this, as I mentioned earlier, is that decision trees are pretty quick. But when we were running lots of decision trees, is that it's a little bit slower. So we ended up implementing this as a UDF in PySpark in order to make sure that we quickly and easily scale to a large number of stores and a large number of trees, and efficiently build many decision trees for many stores in an efficient manner. So now we have our decision tree optimization, which selects the optimal decision tree. And from that tree, we're able to pull out the rules around how we got to those pockets of high inaccuracies. But then, so what do we do with our rules, and how do we kind of relay that to our end user? Well, so what we did is we have this kind of output right here, which is a mock-up of how our output looks when we're conveying that to our end user. Basically, the idea is that we want to give an overview of the different focus areas that the restaurant manager wants to focus on in order to identify those high pockets of inaccuracy rates. And then based on those high pocket areas, the restaurant manager can think about, well, how can I take those pockets and understand the process that went into the situation of time, and use that to help smooth out some of our operational challenges in the future. So we wanted to think about this in terms of the end user. So if I'm a restaurant manager, what I want to do is look and see exactly where my areas of opportunities are. What happens in those cases where I have inaccurate orders? And that's what we have in the left column there. We have the outline of the different business scenarios that occurred when those inaccuracy rates were high. Then the next column looks at the total cost of those refunds to our restaurants. So when we have those inaccurate orders, customers get a refund, that refund costs us money, and this shows us exactly how much for each little focus area. Next, we look at the total customers served and the total customers with an inaccurate order to kind of give the restaurant manager an idea about what kind of numbers we're dealing with. And then we have the percentage, of course, of those orders that were inaccurate at the right column. At the top, we also count up the total percentage of inaccurate orders, both in terms of counts and in terms of dollars, so that restaurant managers can look at that top line and understand just how much of those inaccuracies were accounted for in those two given focus areas. So this is important, right? Because as a restaurant manager, what they want to do is see what happened in the past, what patterns kind of happened in the past that weren't ideal. And then from there, the restaurant manager can kind of take those ideas and use that to implement operational improvements at the store level, because they have a much better idea about how to do that than we do. They just don't know where those patterns are in the past. So we're kind of meeting together and showing them exactly where those shortcomings are, and they can come up with a plan for the future in order to fix those shortcomings. So that's basically how the tool works. But the next challenge is, how do we deploy it so that enough users are able to get their hands on the tool and use it the way they want to use it? We ended up deploying this as a web application. Deployments can often be challenging because there are a lot of different ways to deploy something, and the best way to deploy something will depend on your organization and a project and a variety of other factors. In our case, we thought a web app was the best option for deployment because they're easy to share. You don't have to have any other existing tools to use it, and you don't have to worry about any permissions or anything that might be confusing with other types of applications. So web apps are very easy to use and very easy to share. We worked with an engineering team to deploy this as a web app using a lot of tools such as Node.js and React. We also made sure the tool integrated with other internal tools in order to ensure easy access for the global markets. And then the modeling process was scheduled using Databricks, and a lot of the data we store was also stored in Databricks as well. So we use that to kind of orchestrate the different models behind the scenes. So how is the rollout going since then, and what kind of reception has it received? Obviously, we have this plan of how we think the tool should work, but it doesn't always translate to how people use it in actuality, right? Well, in this case, we kind of identified a handful of markets to roll it out to. McDonald's is a very global corporation. Every market kind of works a little bit differently. So we've identified different markets that we rolled out to kind of on an individual basis, and we're doing one rollout at a time. The overall support of the tool is that it's been very easy to use, very useful, and that it's able to identify patterns that managers did not necessarily know of before. So that's all stuff we really want to hear. As far as next steps, we're continually trying to iterate on this tool and make sure that it's the best stage that it could possibly be. So we continue to work on performance improvements, continue to add features. We continue to have a dialogue with the markets and the users to make sure that they're using the tool in ways that helps them. And if there are any new features they want to see added, then we can think about adding those as well. There are a lot of things we could do with this tool to scale it up, including forecasting and customer satisfaction metrics, other metrics to be added as well. But at this time, we're just working on rolling it out and kind of planning about what a V2 might look like. So I kind of wanted to end up with a couple of lessons learned that we were thinking about as we kind of went back and looked at what we did for this project. I think there are a couple of key lessons that we can kind of pull out. The first one is to continually engage with the business and stakeholders. Communication with the business ensures that checkpoints are met and everyone is working towards the same goal and on the same page of delivering a good project. It's important to always consider the strengths and limitations of your data. Things like scale, balance, accuracy, quality are all key aspects of a data set that will help dictate what your optimal solution should be, and will help you dictate what kind of tools you can use and what analysis you can use on your data. So always keep those things in mind. It's also important to work iteratively. There are always multiple ways to get to a solution. So make sure to iterate through different strategies, pivot when needed. And if you're working with stakeholders, make sure that both sides are on the same page about what we're iterating on and different strategies that you guys can try. We learned that solutions don't need cutting edge strategies to drive value. Everyone likes doing the fancy machine learning methods and neural networks, but a lot of times explainability is very important. So don't forget about the more straightforward vanilla methods, because those could be just as impactful. And last, the main priority is delivering value for the business. I think sometimes it's easy to forget that data scientists exist to serve the business. So all projects and analyses should be focused on the same end goal, which is driving value.